Now we introduce an interesting phrase mining method called ToPMine, which mines quality phrases without training data. This method actually belongs to strategy 3, as we just discussed. We first do phrase mining, then do topic modeling. Why we want to do that way? We can see if we use a strategy 2, we first do topic modeling, then try to do phrase mining, we may encounter some problems. For example, let's look at this example. Suppose we first do topic modeling in this one. Remember, the topic modeling usually generates a large number of topics. Suppose knowledge discovery, you see knowledge is in the red topic and discovery is in blue topic. Okay. Same thing as support vector machine, you may get a support is in one topic, vector is in another, and the machine is in the topic the same as support. Okay. If that's the case, we will never be able to generate knowledge discovery or support vector machine as quality phrases because they belong to different topics. Okay. How can we fix this problem? If we switch the order between phrase mining and topic modeling, that means we first do phrase mining if we can find knowledge discovery is a quality phrase, and least squares is another quality phrase, and support vector machine is a third quality phrase. Then we will be able to generate the very high quality topic models. For example, knowledge discovery is one topic, least squares is another topic, support vector machine is another topic. Can we do that? Okay. So the trick is we can first do phrase mining, then we do document segmentation, then we do phrase ranking. After that, we take those phrases as constraints. Then we do topic modeling inference. Then we will be able to get both high quality phrases and high quality topic models. Let's look at this method, ToPMine method. The method was developed by Ahmed Erkishkis and his team, published in VRDB 2015. First do phrase mining, then do phrase-based topic modeling. The phrase mining is first mine frequent contiguous patterns, then we can extract these candidate phrases and their counts. This method is very much like a typical frequent pattern mining methods. Then we can agglomeratively merging those adjacent unigrams guided by significance score. We are going to introduce you a little later. Okay. Then we can do document segmentation. That means we will work out based on the raw frequency, based on going back to the document to see which one will count which, we'll get a rectified true frequency. For example, just give you a simple example. Suppose we have support vector machine as a phrase. It occurs 90 times. Then vector machine as a phrase, it occurs 95 times. Support vector occurs even 100 times. However, you go back to the documents, you will find if you count support vector machine as a phrase, you will not recount vector machine as independent phrase or support vector as independent phrase. You actually will decrease their count substantially. Okay. That the count is what we call rectified frequency. Our analysis can be based on rectified frequency instead of a raw frequency. Okay. Then we can rank those phrases based on popularity, concordance, informativeness, and completeness, as we just discussed in CURT. After this, we can do phrase-based topic modeling. That means we can, taking those mined bag of phrases, we pass them to phrase LDA, which is an extension of the LDA. This method will constrain all the words in the phrase to each sharing the same latent topic In that way, we will be able to derive better quality topic models. This method essentially doing collocation mining. That means we will find a sequence of the words that occur more frequently than expected. Then we will say they likely should be a phrase. Okay. For example, if you see strong T, okay, you see it happens frequently together. Then you look at the strong, how many times happens T, how many times it happens. Then you see strong T happen together more frequently than expected frequency. That means a strong T should be a phrase. How can we measure such things? We can measure this based on different measures. For example, the mutual information. Okay, and this essentially is pairwise mutual information. And we can do t-test, can do z-test, can do chi-square test, can do likelihood ratio. Actually, using all the different methods, we can confirm the phrase we generate are truly good phrases. Usually use any of the good measures will work. Okay. That means many of these measures can be used to guide the agglomerative phrase segmentation algorithm. Let's look at the example. Okay. Suppose we have a bunch of documents. One says Markov blanket feature selection for support vector machines and all the others. Okay. How can we know, okay, without training, to see feature selection should be a phrase, support vector machine should be a phrase, Markov blanket should be a phrase? Actually, the trick is very simple. If we think about the normal distribution, the Gaussian distribution, by basic statistics, we know if you got a Gaussian distribution, you get one standard deviation away. Actually, it's about the chance to get this is 1 minus 68.2%. But you get 3 standard deviation away. The chance is very, very small. Simply says you only get 0.3% of chance to have 3 standard deviation away. And then how do you explain it? Likely they should get together as an exception, not as a random distribution. They should be a phrase. Okay. We can use some significant score, like a Church developed in 1991, right on this formula. This is very much in the same spirit as z-score, how many standard deviation away. Suppose in this document we found a support vector getting together is about 12 standard deviation away. Okay. That means actually support vector getting together is so tight, so unusual, they should be a phrase. Even you merge support vector as a phrase, then you still calculate this machine, you find they are still 8 standard deviation away. Simply says support vector machine getting together should be a phrase. An interesting case could be you see feature selection, some people see selection for. Which one should be a good phrase? Actually, if you check the whole documents, you see feature selection likely should be a good phrase because they getting together is more than expected. Okay. Then you team up with feature selection as a phrase. In that case, the selection for will not be a candidate in this case. If we do phraser segmentation, feature selection will have a count. Selection for in this particular sentence will not contribute to a count to selection for because feature selection is already there. Okay, so if we do the good rectification of the phrase frequency, we'll be able to make a very good judgment. So we did some good experiments. You probably can see if we use DBLP, which is computer science research publication bibliographic database, we actually can see the unigram generated and the n-gram generated. It's already better quality than purely topic modeling. However, you see this n-gram generated are very informative. For example, almost anybody working on natural language processing, you probably can see natural language, speech recognition, language model, natural language processing, machine translation, all these become very, very good top-ranked phrases for natural language processing. That implies this phrase mining not only helps generating quality phrases, but also generate better quality topic models. That means ToPMine is efficient and generates high quality topics and phrases without any training data. Similar experiments on Yelp. Yelp actually is a social media data sets. For Yelp reviews, people writing something not quite formally, but still we probably can see the phrase generated are actually pretty high quality. For example, if you look at this, Mexican food, chips and salsa, hot dog, rice and beans, you will see these are the very typical Mexican food you can generate using this phrase mining. First do phrase mining, then do topic modeling. One thing we should note is, for example, food was good, generate here. Food was good actually is a sentence. It's a short sentence. It's not a phrase. If we add a little more, for example, part of speech tagging, we will be able to rectify it, get rid of this food was good as a short sentence. It's not a phrase. The remaining ones are pretty good. So that implies ToPMine, and it can further integrate with some natural language processing features. Then we will be able to generate pretty high quality phrases for the subsequent processing.